Welcome to an exploration of animation and rendering, where we delve into types, principles, web animation, VFX, and rendering algorithms. The animation industry is booming, with cinema animations running at 24 frames per second and a projected market value of $270 billion by 2028. Disney's 12 principles and VFX render times are pivotal in this growth. Animation is the art of creating the illusion of life by displaying a sequence of images in rapid succession, where slight changes between each frame produce the perception of movement. At its core, it relies heavily on timing, spacing, and rhythm to make characters and objects feel believable and expressive. Whether hand-drawn, computer-generated, or stop-motion, animation brings static visuals to life by simulating motion, emotion, and storytelling. This blend of creativity and technique has made it a powerful medium for entertainment, education, and visual communication across the world. 2D animation relies on traditional techniques like cell animation and vector graphics, while 3D animation uses keyframes and motion capture for a more dynamic experience. Disney's 12 principles of animation form the foundation of creating believable and engaging motion in animated works. Techniques like squash and stretch add flexibility and weight to objects, making movements feel more dynamic and natural. Anticipation prepares the audience for an action before it happens, improving clarity and realism. Exaggeration enhances expressions and actions to make them more visually compelling and emotionally impactful. Together with the other principles, these techniques help animators create characters and scenes that feel alive, expressive, and immersive, greatly enhancing storytelling and audience connection. The computer animation pipeline is a structured workflow used to create digital animated content, where each stage contributes to building a complete and believable scene. It begins with modeling, where 3D objects and characters are created, followed by rigging, which adds a skeletal structure so they can move. Animation then brings these models to life through motion and performance. In the lighting and VFX stage, visual atmosphere is enhanced using lights, shadows, and special effects to improve realism and mood. Finally, rendering converts the entire scene into final images or frames, producing the finished animation seen by the audience. Web animations use technologies like CSS, SVG, and HTML5 canvas to bring motion and interactivity to web pages, making digital experiences more engaging and dynamic. CSS animations are commonly used for transitions, effects, and UI interactions due to their simplicity and efficiency. SVG animations allow scalable, resolution-independent graphics to move smoothly, making them ideal for icons, charts, and illustrations. HTML5 canvas provides a powerful drawing surface for more complex, frame-by-frame animations and interactive visuals, such as games or simulations. Together, these tools enhance user experience by making websites more responsive, visually appealing, and interactive. Rendering algorithms are techniques used to generate images from 3D scenes, and rasterization and ray tracing are two of the most important approaches. Rasterization works by projecting 3D geometry onto a 2D screen and determining which pixels correspond to each shape, making it extremely fast and widely used in real-time applications like video games. Ray tracing, on the other hand, simulates the physical behavior of light by tracing rays as they interact with objects, producing highly realistic effects such as reflections, shadows, and refractions, but at a much higher computational cost. While rasterization prioritizes speed and efficiency, ray tracing focuses on visual realism, and modern graphics systems often combine both to balance performance and quality. Thank you for joining us on this journey through the fascinating world of animation and rendering. We hope